In the last video, we talked about a situation in which an engineer might want to do their design using algebraic relationships as opposed to calculating specific values for everything. And there are a lot of situations where you'd want to build that flexibility into your design. In this video, I want to use Fusion 360 to illustrate more clearly the input and output nature of functions. As you can see in this triangle, we have two sides of the triangle that have been defined parametrically, and I know that because of that f of x. What that means is that these two sides have been defined as dependent on the third side. In math, we would typically talk about the independent variable as x. It is the input into our functions, and when we plug x in, we get some value out for y. Y is known as the dependent variable, and the way it's dependent on x is defined by whatever your equation is. Notice this, when I go and change my input value, say from 3 inches to 4 inches, the other two both change along with it, and they change according to the formulas that define them. They are dependent upon the input. And I can go in and continue to change those sides. So again, notice input, output, independent variable, dependent variables. One depends on the other, and they are defined by those functions, whatever functions that I put in. Now, in Fusion, if I hover over these measurements, it will often pop up what the formula was. So in this case, I have defined this side length to be L. L is 5 inches. This side is defined as L plus 1. So if L is 5, this side will be 6. If I change this to 6, then this side down here now becomes 7. This one is defined as 5 times L divided by 3. So a much harder relationship to see. But once again, you can see input and output, and that is the function. Now, as an engineer, I might want to see all of this information in one spot. And so if I go to the modify panel and I come down to where it says change parameters, you'll notice that f of x there again from math class. And this will display a table that shows all of my variables, what they're named, and what equations are used to define them. Here I have this expanded out, so they just say linear dimension. In this case, it's 2 because I had done something earlier, so it seems weird that it's starting with 2. There's a reason for that. I have defined that to be L, but here I can go and change that to something else. So I might say length. D2 just means next dimension. And I might change that to width. That doesn't really make sense for a triangle, but we'll roll with it. And you'll notice that when I change that, it also updated the formula. And so we can name those, and we can see the formulas that are used to define them. I can also edit those formulas. Now, I want to be a little bit careful here because of triangles and the way triangles work. There are sometimes impossible values that you could have, but we'll go ahead and see if we can change that to +2. And it did. So now we have 6 plus 2 instead of +1 to get the side length. And then, of course, we have here 5 times the length divided by 3. If I change my base value, say from 6 to 3, all of my current values should change along with it. And if I click OK, you can see that my model on the design screen was updated to correspond with the changes that I made in that panel. So this, again, is to illustrate input, output, and the value of having a formula to define our variables relative to each other.